like this, with your eyes going in one direction and trying to concentrate on something over here. You can't do it. You know, you just have such lousy, your retina is so lousy out here and out here that it doesn't work. And so what do? You turn your eyes and you turn your head so that you're reading with your fovea or your macula, the best part of your eye. I'm sorry. I got it. I didn't see that well enough. Okay? So when we look into people's eyes, the thing that's really right in front of us is this fovea here, and the optic disc is kind of off to the side, like you saw in that ophthalmoscope picture earlier. This picture here has a, this is the lateral rectus, clearly. This is the medial rectus. That's the only ones they really put in here. What bones are these? This is the ethmoid over here. Okay. So let's talk about this middle layer, this vascular tunic, because it not only does it carry the blood vessels into the eyeball and supply the retina and so forth. That's called the choroid plexus of vessels. It also has a specialized part up towards the front, which we call the iris. The iris is part of the vascular tunic. So it opens and closes depending on light. And there's also the ciliary body, which is what those little suspensory ligaments are attached to. But the other thing that the ciliary body does for us is it both makes and it reabsorbs the aqueous humor. We call it aqueous humor because it's so funny, I guess. I don't know why it's named that. But that's the water in the front part of your eye, called the aqueous humor. And this middle part of the eye controls the shape of your lens, which is essential to focusing. The last thing I would say about this is that there was a bunch of lawsuits back in the 60s about maps in this country. And like Rand McNally was a big map maker, and National Geographic made maps, and they sold maps, and that was a big deal. And what these map companies would do occasionally was put in a fake town, or they would put in a fake bend in the road that wasn't really there. But they put it in there so that nobody could copy their maps. And if they did, they said, "Ha, you stole this map from us because that bend is not really there, or that town is not really there." Okay? Now I want you to look at this right here. See that little vein coming out of the middle of the side of the eyeball like that? There ain't no such thing. Okay? The veins don't come out of the side of the eye like that. That's there for the same reason, I believe. That is anatomically incorrect. If you copy their picture, they can come get you if you have that on there. So if you want to copy this picture, just Photoshop that little thing out. And they'll never know. Okay, so let's talk about the pupillary muscles for just a second. So here's a big wide open pupil. Someone in the dark, you shine a light in their eye and it gets small like this. How does that work? Well, there's two sets of muscles that both live in your iris, which is the colored part of your eye here, this part of your eye. And if the inner layers, if these constrictors constrict, the constrictors go around, if they contract, then your pupil gets smaller. The ones on the outside here are called the dilators. They pull it open, okay? So if those muscles contract, then your pupil gets bigger, like this. Okay, so there's two sets of muscles. Now one of them is sympathetic and one of them is parasympathetic. Remember that stuff? Mm-hmm. Which is which?
Sympathetic, right?
Oh, shit, it says right here. I'm sorry. Yes. Sympathetic stimulation makes your eyes get bigger when the tiger walks in the room, and when you rest and digest, you make it smaller. Duh. Okay. Boy, that was a good question, though, wasn't it? A ciliary body extends posteriorly back to the level of the ora serrata. What is the ora serrata? Well, the ora serrata means serrated. It's basically the edge of it's a serrated edge. So when you look at it, it looks like this. You'll see that in your eyeballs, by the way. And it's the stuff that's in front of the retina. It contains the ciliary processes and the ciliary muscles that attach to those suspensory ligaments. They all live in front of the ora serrata. Choroid is that vascular layer on the back. It delivers oxygen and nutrients to the retina. That's why when you have a detached retina and it lifts up, it doesn't get any oxygen and you can't see through that part. Let's stop right here at the neural tunic, the third layer. And